Here's a kind of puzzle-like question. It's filling bricks into a box. Such a question should need a very careful consideration. All right, let's look at the question. What is the maximum number of 3 by 3 by 2 bricks that will fit in a box that has dimensions 13 by 8 by 4 without exceeding the dimensions of the box? So without exceeding the dimension of the box, meaning that the brick has to be fully inside the box. So let's look at the box. Okay, let's draw a box. A box is look like this. So you have dimensions of 13 by 8 and by 4. And the bricks are much smaller, of course. It's 3 by 3. It's a square on one side, and then depth of 2. This is 3, 3, and 2. Now, how you're going to fit this thing? One clear way is you can do the following. So you can fit like this. You can fit about 3 by 3 here, and another 3 by 3, another 3 by 3, another 3 by 3, like that. And then you fit 3 by 3, 3 by 3, 3 by 3, 3 by 3, right? With the depths of 2 there. So basically I can fit 1, 2, 3, 4, 5, 6, 7, 8 if I have a depth of 2, because everyone is going to have a 2 there, right? So basically now, after filling this 8, you're filling half of this depth. Correct? So basically what happens is you can have 2 layers of those kind of 8. So now I have 8 times 2, I already fill in. That's 16. One easy thing that, one easy problem, a mistake you can make is you thought this is the biggest one, because you only have 2 remaining here. If I consider after you filling all those of here you have basically 12, you have 6, you already filled. After you filling this 12 by 6 by 4, you thought this is the best you can do. Now let's look at what's remaining, okay? What remaining is, after you fix this, what remaining is this thing. And here you have a 2. Here you have a 13, all the way to this guy, 13. And in here you have a 4. So up to here is, okay, let's just think about 13 here. This is 13, but here is 12, and this is 1 left. Okay, this is 4 here, and this is 2. In this very narrow box, can we fit in some of this 3 by 3 by 2 bricks? And, you have a dimension of 2 here, and dimension of 13 and 4 here. Clearly, you can fit in some 3 by 3 by 2. And the trick is you have to change the direction of this brick. Now the 3 by 3 has to in this dimension now. The depth has to be on this too. So if I change my view, you should look at a thing like this now. You have 4 by 13, and then you have a 2 here. That's the box that we're talking about. This is 2, 4, 13, 2. And here, how you do this 3 by 3? You can do the following. So in here I can do another, okay, it's not drawn to scale, so this 4 should be much smaller, but I'm going to draw a 3 by 3. So this is 3 by 3, and another 3 by 3, another 3 by 3, and another by 3 by 3. And you have this 2, just fix this, and these are the 4 bricks. You can do another, and I can have fit 4 more bricks. So the total number of bricks can fit equals 16 plus 4 equal 20. And this problem is not trivial. It needs to be very careful. After fitting those bricks, you thought this might be the maximum, but actually there's the slice you can put in this very narrow box, as long as the dimensions are each dimension is bigger than, you can have a dimension that this is bigger than this, and this is bigger than equal to this, and this equal bigger than equal to this. Obviously, you can fit in some bricks, and the trick is to turning the orientation such that you can put the brick in the right direction. And of course, you should think to yourself, in here, when I put the bricks, I put the bricks along the x, y, and z axis. What if I put the bricks with a slight angle? Can I fit in more bricks if I do that way? And that turns out to be true, that you have to, for maximum bricks you put in, you have to put in along the x and y, z directions. But that's a much tricky question. We'll talk about this much later.